We now have a vector representation of a boat desiring to travel from A to B across the banks of a river with a current flowing to the right, and the boat ends up at C. The vector VB, which represents the velocity of the boat with respect to the ground, is the velocity of the boat with respect to the river plus the velocity of the river current, and this is a vector addition. We wish to resolve this resultant vector VB in terms of its x and y components. Let's just take the vector VB with respect to r. This is the intended direction of the boat along the line AB. This line AB makes an angle theta with the horizontal. If there was no current, then this is the direction in which the boat would head in and would also end up reaching B. Let's resolve this vector into its horizontal and vertical components, because what we are aiming to do is to obtain the velocity of the boat VB in terms of its x and y components. We resolve the vector VB with respect to r into VB with respect to r x, which is the component along the x-axis, and VB with respect to r y, which is the component along the y-axis. So the x-axis component will be VB with respect to r times cos of theta, and the y-axis component will be VB with respect to r sine of theta, and here theta is the angle made with the horizontal. Now in the further steps, we will replace the vector along the line AB, that is VB with respect to r, with VB with respect to r cos theta I plus VB with respect to r sine theta j. Now in our original formula, we make the substitution for the vector VB with respect to r in terms of its x and y components. The reason we resolve the vector into components here is because once we have the vectors in the x and y components, we can set up the equations of motion independently along the x-axis and y-axis, which makes problem solving so much easier. The vector VB with respect to r has been substituted here with VB with respect to r cos of theta I plus VB with respect to r sine of theta j. The river flows to the right, so the vector VR will be VR I, and this will not have any y component. Clubbing the I and j terms together, we have VB equals VB with respect to r cos of theta plus VR I plus VB with respect to r sine of theta j. In the next few lessons, we will use these components to find out some interesting things, like how long it would take to cross the river or how to achieve a minimum drift. All of those conditions are dependent on this vector diagram, so if you understand how to translate a given numerical problem into this vector diagram, you will be done with the physics part of it. It is important to resolve the velocity of the boat with respect to the river into its x and y components. so that we can express the velocity of the boat with respect to the ground into its x and y components. This will make problem solving a lot easier.